Hello, this is David D. Hilster. I am a critical thinker, dissident scientist, and if you're not buying exactly what mainstream physics and cosmology are selling, then this is the place for you. There are literally thousands and thousands of scientists from around the world who have been working outside the mainstream for decades and who have identified problems, fixed those problems, and are proposing new theories and models. You won't find anything like this on YouTube, so be sure you go down below and click the subscribe button, the little bell next to it, so you will be alerted when our next video drops. Today I've got a really fun day, something that I sort of put together, and I was thinking about this, that is, how do we go about reading a book on a completely new theory, a completely new model for the universe? How do we do that? Do we just throw it away? Do we just say, no, it's not right because I believe this? How do we approach it? Why do we approach it? So I'm going to do two things today. I'm not only going to talk about a book, a really great and fascinating, amazing work by an amazing scientist who is a member of our group for many years, but I'm also going to give you pointers on why you should read them as a critical thinker. Why waste the time on a model that you may very much indeed think isn't right at all? And you're thinking, why? But I will tell you why. And let's go forth. So today what we're going to be looking at is a book from a good colleague, a good friend and colleague of mine. A good friend in the sense, we are colleagues and we respect each other's work, and he respects the work of me getting all these ideas out there. And that's Vladimir B. Ginzburg. And he is a Russian, and he has this book, The Space-Time Origin of the Universe with Visible, Dark, and Matter and Energy. He's also the author of Prime Elements of Ordinary Matter, Dark Matter and Dark Energy, the Unification of Strong Gravitational Electric Forces. So yeah, right away you can see he's written actually quite a lot of books. I'm going to have a link down below there, and you should be able to click on that and see his many books, his many physics books. But this is his latest one, and I got a copy from him. But before we start, I did say that we're going to talk about why do we read these books in the first place? Why do we do this? Well, I put together a really great list that I finally got, and that's why I'm doing this video today, because I really wanted to think about this. Why do I read these? I think these are great. I get these and I devour them. Well, I put the reasons down why I read these books as a critical thinker. And here we go. Well, reading dissident theories and models. First, critical thinkers are naturally curious. When someone says they have a new model of the universe, man, I jump all over it. I'm writing one with my father. I never planned on doing that. But does that mean I'm not curious as heck about what a person has put together? I mean, someone has spent, as the second item there says, someone has spent a lifetime working on this work. Like this book right here, which I'm going to talk about today. A lifetime. And that is a long time. In fact, we'll look at the back cover of this book, and when we start to get into it, and you'll see this guy's been working on this for quite a long time. Maybe many of you weren't even born when he did start working on it. They're also very courageous. Why? Is because if you are a person who's writing a book, a new model of the universe, you don't go on a lecture tour around the world at universities going, bravo, another model of the universe. This is great. It's got a lot of great features to it, and this is what we like about it. Doesn't happen. We have this idea that science and physics only has laws and things that go on in the universe, and also the way the model is that are written in stone. We know that that is a problem. We know that we cannot continue in science this way because, like any profession, there are many ways and many ideas of way things work. And the idea that there's only one model and one way to skin a cat, as we say, that's wrong. So yes, these people are very courageous, and they're not supported. They're just not supported. That's part of being courageous, is not having the support that you like. Although Mr. Ginzberg actually has, if you look in his book, he does have a lot of physicists and a lot of real good scientists who have actually talked with him and given him support. So that's really very, very good. Also, it's very well documented. Look, this book right here. Oops, that's him on the back side. But this book is quite long. It's 270 pages long, very well put together, very well illustrated. Quite a work to put all this together. And he has many books. This is not the only book he has. So it's very well documented. So you can't say, well, it's just, there are some actually books that are sort of more nebulous, but most of these theories of everything are quite detailed. So that's really good. So you got very good documented work. Critical thinkers also support others' work, even if it conflicts with their own. And I will show you in this book how that is with my own feelings, but my own beliefs, my own critical thinking. But does that stop me from not admiring this work? Does that stop me from not saying, he could be right? You know, whose model is right? And so that's really, really important. We've got to, as critical thinkers, support each other. Even if it's something that, oh, you kidding? I don't believe in ether. Dominant Spencer, don't need ether. And other people say, you can't have light without something, and ether is what they think it is. These are better models than the current model in the universe. You're saying, David, that's a joke. The current model is well tested. No, it's not well tested. It's tested by the people who make them, and they build stuff. They say how they're going to find, for instance, a particle. They design a thing to find it, and you better believe it, they're going to find it, whether whether or not it's real or not. So no, that's just not the case. These models, why do people write these books? Because they think there's problems with the current model. Hello. And if there's problems with the current model, then they are almost always better models, because they describe things that mainstream cannot, or they give physicality to what mainstream cannot, or they describe constants that are, constants are crutches, but those constants that some people say are just this magical number, sometimes books will tell you in their models that these constants actually can be calculated from a simpler model. That's one of the biggest things that you find in these books about new theories. And of course, the last thing that is very, very important, and that's why I put it last for you, is because you find many new scientific truths in here. You're going to find stuff that you are going to agree with that you've never thought of, and that's going to add to your model of the universe. That's why I read this and all the other models, because there are truths. And as Neil Adams, the guy who makes the famous he is, cartoonist, and I admire his work he's done on expansion tectonics, and he has his own model too, and I admire that. I think there's a lot of very interesting and good things about it. But what he says we all own part of the truth. And isn't that the truth? So those again are my points for reading dissident theories and models. And I'm going to bring these up every time I go, because I'm going to start going through some of these books. And I was thinking to myself, wait, I just don't want to just review the books and give you nothing. No reason. Why do I read them? And I love them. When I get a new one, it's like, woohoo! So I'm going to try to transmit these points to you every time. So when we write a book, you're going to see this slide over and over. Maybe it'll change when I try to word it better or correct a misspelling, which I happen to have to do sometimes. Let's just take a look at this book and let's get right into it. This is the author, and you can read a little bit about him here. Vladimir Ginzburg was born in Moscow, Russia. Received an MS degree, Master of Science degree in Mechanical Engineering in 1961, a PhD in Technical Science in 1968. He moved to the United States with the family in 1974, where his principal occupation was the development of computer models for simulation of technological processes. The author of numerous articles and several books related to engineering. You can see those actually on Amazon. I have a link down below. Vladimir Ginzburg holds over 60 U.S. and foreign patents in parallel with his work in engineering. He conducts in parallel with his work in engineering, sorry about that, there's a period, he conducts intensive research in physics. The main topic of his research is the universal space-time theory. And of course, if you hear space-time, you're going to read, of course, think of somebody, and you're absolutely right. But I was very lucky to, I'm going to take this guy down. Thank you, Mr. Ginzberg, but I want to thank you also for getting a copy of his book back in May of 2015. I don't remember where we were, but it must have been at a conference, one of the MPA conferences, or No, maybe the CMPS, maybe the I don't remember, one of our conferences. So you were thinking space-time, and he right in the beginning he says, and the great thing, he puts right up front the essence of the universal space-time theory. But before I get to that, of course you're thinking of space-time, and you're thinking, Dave D. Hilster, aren't you the guy who rags on relativity all the time? Well, this is Space-Time, a dedication. You can read that. This book is dedicated to the German-Swiss physicist Albert Einstein, who, in 1914, presented gravity as a geometric property of space-time. Besides explaining the first time the physical meaning of gravity, Einstein opened the door to search for other physical phenomena to explain the properties of space-time. Einstein was a dreamer. I will not be surprised if in one of his dreams he may have envisioned space-time as the origin of the universe. Now, you're saying, whoa, Dave, again, this is space-time. You say space-time is a joke. Well, space-time is a joke if you don't put a physicality to it. So, first thing you can learn here is Mr. Ginzberg is giving us a physicality for space-time. Yay! So, there you go. Something I can go and be totally excited about and read about this. So you can read about all of this, and you go through, and he basically goes through with lots of math, and two of the things he says he talks about are vortexes and torics and helix structures. So you can see, let me just give you a picture here, elementary particle matter. So he says right here, 4 kinds of elementary matter particles are formed by unification of these polarized toruses: electrons, positrons, etherons, and singletrons. Now, etherons give me the notion that, in fact, he is an etherist. That is, light is going to be waves through ether. And he goes through the structures, the elementary particles, and the structure of helium and 4 nucleus. Look at this. This is really great. I love it. In fact, my particle model with my father, we're going to be starting, eventually get to the nucleons and that, and I see a lot of similarities in the way atomic structure is put together by these new critical thinkers and these new models. In fact, look at this, something very similar to my father and I's model as well. You have space-time levels. You have the levels of the universe, and those levels are given sizes and the like. The definition of dark matter and dark energy. Now, why can he do that? Is because he's putting something there. It's not just a nebulous thing that he's talking about. So we're going on, part 1, Introduction to Universal Space-Time Theory. The ideas related to the universal space-time theory, the age of the ancient, and he goes into, this is another thing that I should have put on my list. Make a note of it, Dave. You get some great reinterpretations of history. Got to put that down. Reinterpretations of history. Got to put that on my list. So next time you see a book review, and he goes into that. And I actually started rereading this because I read it before. And he goes through the age of ancient Greek civilization. Starts out of 611 to 547 BC. And talks about great scientists on whose shoulders he stands. He goes through Pythagoras. My gosh, I can't even pronounce some of these names, so I won't even try. Archimedes there, of course. The age of classical mechanics, Kepler. He talks about Descartes and Huygens, Christian, the Dutch physicist and astronomer. And on and on. So you can see that's one of the things that you get in this. You get great, you got to get history, but you get great data from real experiments. So I write this down, and those will be something that you could use for your own work or be inspired by. Coulomb, Faraday, goes on, Wilhelm Weber, I'm probably sure it's from Germany. Yep, German physicist. William Thomson's presentation, electromagnetic wave. And then There's smoke rings. Somebody else who does smoke rings is James Carter. From where? Physics on the Fringe. The book where they actually, the author actually wrote a little bit about me in there. Oh, I'm real famous, right? That's all right. A really good book. I have complaints about it, but that's okay. But it's still a good book to read. And so you go on, and he looks at the propagation of light, atomic and nuclear age. He starts to talk about that. E equals mc squared. And, of course, they have very well, it just keeps going. This chapter 1 goes on and on. A very great explanation of the history of what these scientists, when they make their models, are looking at and what they have been inspired by. And again, these sometimes are better historical records and with new data that other people don't see in the regular books. Heisenberg, man, just goes on and on and on. And he talks a lot about the Penrose twistor. Now look at that. So you can start to see that he's been very influenced by some of the flows of things and the way fields and all those things work. So you can tell toroids flowing, different types of manifolds, that kind of thing. Very interesting. And then you have even the quark compositions of several particles. So there you go again. You can see, and there's my favorite thing. That's how they're made up. They're circles with little circles in them. That's why I love books like this, because hopefully these guys will start to look at the real physicality. But he's going through chapter 1, going through all of these things, saying what's important. Then he gets into vortices in nature, etc. Again, vortices are very prominent in some of these theories. And he talks about even the DNA helix. He talks about, and then he gets into chapter 2, multidimensional space-time. Dimensions of space are often frequently defined by a minimum number of coordinates needed to specify a location. Here's how to create a multidimensional spaces in accordance with Euclidean geometry. There's fourth dimensional Riemann's multidimension. So he is into multidimensions. I am not. But I still look at it because you can find some really, really interesting things that you're not going to find anywhere else. Again, you can start to see he's starting to set up some of his own ways of making structure to the universe. Static and dynamic helical spirals. So that's chapter 3 right there. You can see it's very well put together. He's got math in it, but the math is pretty much geometry, functions that are force functions, the universal helicola. I don't know how to pronounce that exactly, but he talks about the solar system. So you can see these people are looking. A lot of times people say, "Yeah, these new theories are just really simple. They don't look at things. They don't realize the complexity of the universe, and they try to simplify it because they have simple minds." Absolutely couldn't be further from the truth. Part 2, elementary matter particles. So now we're going to get into this the basic context of the torix, and he says torix. There it is. And that's what he's going to be talking about, and he gives all the mathematics. Chirality, which is left-hand rule. I'm sitting here on the side here. Should do this. Oh, that looks more interesting, huh? And he's talking about the toric space-time postulates, and he has, in this fact, equations of relative space-time, in parentheses, lead string, radius, wavelength, and he gives you the mathematics for his theory, and very specifically for rotational velocity, spiral velocity, frequency, the whole thing. An immense amount of work. I mean, I admire these guys, and they don't have the support of any university or anybody. Space-time math, elementary number line. Look, we talk about the number line, and I talk about the number line with one of my favorite, Peter Erickson. one of my favorite mathematicians, maybe my favorite of our generation. Infinity versus infinity versus infinity. Whoa. So he talks about that space-time trigonometry. It's really incredible. I mean, if I keep flipping through this book, usually I'll flip through a book pretty quick. Trends of toric space-time parameters. And he talks about that. You can see the graphs that he comes up with, translational velocity of trailing string. So I guess strings are part of his theory. And again, it sounds, he just puts everything into it. No, it's quite well thought out and put together. Again, I've read through this already once, but I'm sort of going this. Inversion states of torics, inversions leading strings. So he's starting to put these things together, and he gives them dimensions. I mean, where do you see that in mainstream? You don't. You see sort of these general things, and they smash things together, and things are energies, and then they invent all kinds of physical, and as Alexander Unziker says, they invent arbitrary attributes and arbitrary packages. Space-time conservation law. Got to conserve science. That's another thing. People think when you write books like this that your theory violates. It violates conservation of energy. It violates conservation. These people are not that dumb. They are very intelligent, critically thinking people. Could have easily gone into regular physics, but they say there's too many problems, and maybe they're smarter. I always said that to be a critical thinker, you really must be even smarter than the mainstream people, because they don't see the problems or they don't do anything about it. Or maybe just have the cojones to do it. Electron, positron, etheron, and singleton. Torics, he starts to then use all this stuff to put together the 4 elements there. You can see the torics, and he starts to give the exact math to these things, their sizes. Oh, heaven forbid that we'd actually have physicality to what he calls this space-time. Physical properties of microtoruses. Again, just lots of math as well. And it's not just math that he just sort of puts together. It's all built on his system. This is amazing. We're at page 159. Lots more graphs from quantum vacuum to atoms. There you go. That's what he's saying right there. Formation of harmonic trons, the nucleon crystal structures, oscillated and excited trons, the nuclear cores, nucleons, and on. Now, of course, one of the people say, what's he going to have a different periodic table? No! You're building on science the things that we consider to be very solid. We will, in fact, build things. So he goes through and literally goes through each one of the particles and really details them out. There they are. Quite amazing. I'm serious. I just totally... And there's the nucleons of... And I'm starting to see patterns here that these nucleons are made up of spherical things together. And again, calculating basic excited singletron. And he starts to not only talk about what they are, but how they move, act, react, what kinds of properties they have. He even gives them symbols. And then he starts to do the structure of tritium nucleus. So these are really real structures of nucleus. You don't see those. What do you see with my favorite drawing of the circles? Remember those? The circles? Where are you? Right here? That's what theirs is. It is two-dimensional at best, but he is already talking about how those work, how the structure of tritium nucleus, helium-4 nucleus, those things, all of those elementary radiation particles, and he talks about those concept of elementary radiation particles, and on and on. And again, trends of helix space-time and parameters, just quite amazing. He even has sort of his, very similar to Jeff Yee's work in the sense of almost like what Jeff Yee says, a periodical table of subatomic particles. So very similar. And he has other books where he talks about much more in detail, I believe, of atomic structures and all that. But that gives you an idea. Now you're thinking to yourself, why would I read this? This is full of math. This is full of stuff that I cannot maybe read myself. Yes, I'm a mathematician, so I don't get afraid of the mathematical formulas, but maybe you are a person that is someone who sort of gets turned off by it. Why would you read this? Well, we go back to our slide 2. And the reason is you're going to find something in here. These are a lifetime of works, but you're going to find something in here. And that's what always happens to me. I go flipping through it. I look at it. I read here and there. Something will catch my eye. I will read into it further. I really get interested, and I go, wow, how does he do this? And you end up finding that. I tell my dad all the time, hey, a new book by so-and-so just came out. Let's read it because they have really great descriptions of models that they've come up for the nucleon, for the nucleus of atoms. And my dad says, yeah, that's cool. Let's take a look at it because we ourselves are going to have to deal with that. So, this is a great exercise for all of you. People spent a lifetime doing these things, and they are not ding-dong people. They're not crazy. This guy is an engineer, a real engineer. They have patents. This guy is not somebody, and he even stands much more than I do on the shoulders, for instance, of Einstein. And again, why am I okay with this? Is because I always say space-time is nothing. He is giving a physicality to what people call space-time. And that's really, really important. That's what a critical thinker would do to solve that problem. And that's certainly what Alexander Ginzberg has done in his book. And I am David D. Hilster, and you know me. And don't take my word for it. Or even Mr. Ginzberg. Don't take our word for it on faith. Stay critical. Stay thinking. I am David D. Hilster, your science therapist. Ciao for now.